So I will record this one here in this computer so we can have some memory of this one here. Okay. The only problem is that forum takes a year to answer, but in any case. Do you see my white screen, guys?
Yes,
So,
you're good.
yeah. So let me test if I can write. Yes, I can write. Perfect. Excellent. Okay, guys. So the type of language that we're going to be using. Sorry, I need to be looking at my other screen. I don't know why my pen doesn't work in this screen. So I will be in this screen here. So what we're going to be using first of all, guys, is MATLAB. Okay, and basically MATLAB is a second generation type of coding. It's not like C++. It's not like D. It's more like it's in between. It's in between. Let's say kind of a compiled program like C and Python, but much more closer to Python. Okay, so this implies that MATLAB has a huge library. It's more or less like Python. Okay, so the libraries in MATLAB, remember that MATLAB was created for engineers. So the mathematics and the calculations in MATLAB are precise, are extremely precise, are made for engineers. Make sense? And how MATLAB works? Well, the coding is very intuitive. So you basically write like you're talking. It's not LLMs at this point, but the code is very intuitive. Okay, the loops, the way you write, everything is extremely intuitive. And what has MATLAB, guys, what we're going to be creating is, well, we're going to create something that, some coding, and the name of the code is always ending in .m. Okay, so you put the name .m. This is going to be the name of the files. Got it? Now, a code works in terms of a function. And a function simply allows you to write code. And what is interesting, guys, with one function, you can call another function. And we're going to be experts on that. And the idea when we create a program, guys, is to be as efficient as possible. Okay? And efficiency in programming normally goes in hand with mathematics. Okay, so what is the most efficient way of programming when you are talking about economics and finance is using vectors and matrices, right? So always vectors and matrices are going to help us a lot. So that's why we're going to invest a lot of time on just describing vectors, matrices, and how we can use them to help us create more complicated programs. And also remember, the data comes in matrix forms. If you just take a look to Excel, for example, you have columns and the data comes in the rows. You can assume this is a matrix. Got it? That's it. And what I will show you first of all, guys, is some of the language. We're going to invest a couple of classes playing with language, new words, new techniques, etc., in order to make you proficient on more complex coding. Got it? But everything is going to be applied. So what I do, I expect you to do in your MATLAB directly. Got it? Makes sense to you? If you have troubles, you let me know. At the very beginning, you're going to see it's going to be a kind of slowly because not everyone is catching up fast. But I prefer to do this slowly, the first couple of classes, because the third and the fourth, everyone is going to be by yourselves. And also remember, guys, that coding, you can have an idea that works, and someone else can have another idea that also works. Got it? So there is not only one way of coding. Of course, there is always ways of making your code more efficient, but the thing is that don't focus on a single solution. If you find a solution at this point, even though it's not the most efficient one, I'm happy with that. You get efficiency by programming. Okay, when you do research, when you start working on coding, that's when you really get very efficient. Make sense? Okay, so let's go and let's start working with something. The first part of the language of MATLAB, guys, is variables. Now, this sounds like mathematics, right? So MATLAB uses variables. Okay, and a variable is a name. Basically, you need to define this as a name. I can call X. And what you do is you assign to these ones here values. Got it? And then you can do with these values, with these variables here, different things. You can do linear algebra, matrix algebra, you can do optimizations, you can do whatever you can imagine.
Lucas está viniendo como media hora. Lucas y Joan están viniendo. Voy a textearles.
Okay, so values. So that's what we're going to be doing. So let's start working with MATLAB. Can everyone open MATLAB, guys? So let me stop sharing here. And let me open MATLAB. And let me share my screen again. Do you see my MATLAB, guys, open? Yep, perfect. So let me move the picture somewhere here. Okay. So this is the common screen of MATLAB, guys. Okay, what we are going to be working at the very beginning is in this part here that is called the command window. All our work is going to appear here in this upper part that is called the editor. You don't have anything at this point. You're going to create a lot of programs later. And then you have the active variables are going to be in the right-hand side. You see my mouse moving, right? And in the lower side are the command history. Okay, so everything that you write here is going to be stored in this right-hand side. Make sense to you? Okay, so let's start doing a very silly example. Okay, let me check. So let's write. Let's do. We want to go to a grocery store and we want to buy sugar, rice, and flour. Okay, and pounds. Let's take a look. So let's write sugar equals 4. So sugar, guys, is simply a name. Okay, this is my x variable, and I'm assigning to this variable the value 4. That's all what I have done. Okay, so one thing that is interesting, if you write a semicolon, what MATLAB is going to do is going to store this in memory, but it's not going to show this in the command window. Let me give me 1 second. I was working on this in the morning, so let me clear my workspace and clear my commands. Yeah, okay. So now I can go to my editor. So I was saying sugar equals 4, right? So take a look to the difference, semicolon, no semicolon. If I don't write semicolon, MATLAB is going to repeat what I have said. Now, if I write the semicolon, MATLAB stores this in memory and doesn't show it. Okay? So now let's go with sugar. Let's go rice, whatever you want. Let's say rice equals 7, semicolon. I don't want to show it. And flour, let's say 10. Make sense? So now, one thing that you need to know, guys, is sometimes you want to know what you have in memory. So if you want to know what you have in memory, active in memory, you simply type whos. Just type whos. And then you have the complete description of what you have. You have one variable that is called flour. The size is 1 by 1. And number of bytes is 8. And it's a double. Double, guys, means it's a real number. Got it? So we have all the definition of variables here. Another thing that you need to know is the famous CD. This is all DOS system. I don't know, you haven't seen DOS systems. Well, Trevor, for sure, right? CD is current directory. So you want to know where are you. So if you just write CD, this is where you are. So I am in a summer 2026 programming MATLAB. This is my current location. You can change the location as you want. It's extremely easy. If you want to go back to one below, so for example, I want to go to programming, you do CD space 2 points. And this is going to move you from MATLAB files to programs. I don't want to do this because I want to stay here. Okay, so let's do something simple. Let's assume, guys, that we have prices. I will say P sugar It's too long. PS is price of sugar. Okay, let's say this is equal to 2. Let's say that the price of rice PR equals 3. And let's say that the price of flour equals 1. Now, MATLAB and any other program, guys, there is a difference between caps and low caps. They're completely different. So caps P is completely different than the small p. Make sense to you? So be careful with that. So these are my prices. What I can do now, guys, is my total cost. So I want to know how much money I'm paying. So I will write C. And C is going to be equal to what? Price of sugar times sugar. Do you agree? This is completely inefficient programming, but it doesn't matter. Plus price of rice times rice plus price of flour times the quantity. Oh, sorry, I need to, there's 2 more people coming in.
Opportunity for other question with MATLAB.
Yeah, go ahead. Let me check it.
Oh,
Hey,
sorry.
Siki, how are you doing? Okay, do you hear me?
Hi, sorry. I was just in connecting external display screen,
Perfect.
and the microphone and the camera didn't work very well.
Now you're okay. So you hear us very
Yeah,
well,
I can
right?
hear you.
Perfect. Okay, Siki, so let's do, I have someone else. Laura Marie.
Hi, Professor.
How are you
How
doing,
are
Laura
you?
Marie? Good,
Good.
good,
How
good.
are you?
Very good. Okay, guys, so let's continue. We have just started the class, so give me 1 second. So let me close this one here. Yeah. So I was basically defining variables here. Okay, I have sugar, rice, flour, the command whos that basically allows me to know what I have in memory at this point. CD simply tells me where I am located in terms of directory. And then what I'm doing is simply I define quantities here and the prices here. Price of sugar is 2, price of rice is 3, price of flour is 1. And then I simply want to know what is the total cost that I'm using. Okay, so I don't do the semicolon just to show you the number. So I need to pay $39. Agree? Everyone's with me? Okay, so why it is beautiful to work with variables and assign values to the variables? Because you can change the values very quickly. Do you agree? So for example, guys, I have decided to buy more sugar. Okay, so if you do SU and press the up arrow, guys, you're gonna go back to something that has a kind of similar writing. Okay, so instead of 4, I want to buy now 10. I'm buying a lot of sugar. So what is my cost? Simply write C up. Again appears a formula, and then you simply recompute everything. Make sense to you? Easy, right? So now so imagine, guys, that the store is going to make a discount of 10% in the price of flour. So the store is offering 10% discount on the price tag of flour, 10% of one. So you're going to pay 0.9. Can you do your cost now? So what is the new cost?
So it's 10% off, was the
Yeah,
question?
10% off of floor price.
Oh, of floor, not C. Oh.
Yeah. Okay. Well, I will write C again. And then basically what I'm saying, if I do a discount floor, I don't want to be changing the number, right? I just want to have this as a formula. So I will multiply this times 1 minus 0.1. Can be? And here we go. You have 50? You get 50? Okay, and then you can start playing with this one here. Of course, guys, you see that this one here is a kind of efficient because I need to go back always up and up and up. But let's stick with this for a minute, okay? Later, once we start doing our M files, you're gonna see that you don't need to repeat all the time. But for now, let's focus on and let's set this one here. Now, there are a lot of
Professor.
yes. Go
Oh,
ahead.
sorry. I'm
Lorraine.
so sorry for arriving late. I'm using the email that you sent. That's the Word doc. Am I missing any other documents or no?
No, nothing.
Okay,
We're not yet using the word
Okay.
document.
Okay, got it.
Just doing this part here.
Okay, thank you.
Nothing.
Sorry about that.
No problem.
Yeah.
What I was going to tell you? Yes,
Question
Alfredo.
for MATLAB, I know it's data you can add comments by adding like an asterisk.
yeah.
Is there anything similar here? Or?
Yes. So for adding comments, you do the percentage term, and then you say this is a comment.
Okay, thank you, sir.
Okay. And this is extremely useful when we start doing programming. So now that we are here, can we do give me 1 second. Let me do, allow me 1 second to stop sharing. Let me go back into my screen. I will give you a couple of commands, okay? So guys, if you do, for example, clear, okay? So clear is one command that simply cleans the variables that you have on memory, okay? So I want to clear sugar. Let's do who's first. Sugar is here, do you see that? Okay, so now let's remove sugar. Now let's do who's. No more sugar. Okay, now there is something that is really important for you guys is that when you start running program, there are some times in which you have infinite loops. What is an infinite loop is that your program is going to be running forever. It's never going to stop. Okay, run, and then you need to stop the computer. The way you do that is you press Control and at the same time pressing Control C. Make sense to you? If you want to stop the program running, Control plus C at the same time. Make sense to everyone? Now, if you want to quit MATLAB, you simply type quit. Of course, I will not type quit now because I don't want to quit. Just quit, you get out of MATLAB. Well, what MATLAB is math. So everything that is math, you can do in MATLAB. Sum, subtractions, multiplications, power, whatever you can imagine, absolute values, ceilings, floors, anything that you can imagine, MATLAB does. Okay? So the only thing that we need to know is that if it's scalar mathematics, all the operations work. We just need to be careful about when we talk about matrices, we need to be very careful about the number of columns and rows. Remember the laws of matrix multiplications and matrix handling. We're going to see that later. Don't worry, we're going to go into the details. Something that is also useful, for example, I want to do a help something. I don't know, help SQRT. The command help is your helper. Okay, if you want to know something about a specific command, you just type help, and MATLAB is going to provide you something like this. Help gives you the way you need to use this one here, tells you what you're going to be doing, what this command does for you, etc. This is your help space, whatever you want to do. There is another one. This is when you know the command. There is another option that is called the look for. Look for. And look for is more generic. I don't know exactly the command, but I just want to look for something. I know, for example, a complex. I want to work with complex numbers. Okay? And you just ready for Control C, because it will run a lot. Ready? Let's go. Control C, stopped. You see, and here it provides you everything that MATLAB has that contains complex. You know that if you haven't stopped Control C, it continues running. Make sense to everyone? So this is my look for command. So let me clean this part here. So if you want to clean, because I made a mess now, so you go home, clear workspace, and then you can clear commands. Here we go. Got it? If you want to do it. If you don't want to do it, you just keep the things that we have done. Let's go back to editor. We don't need to do that, but let's go back to editor. Now, guys, let's start using vectors and sequences, okay? For now, let's type the following. So what I want is to create a variable x, that is going to be, when you want a vector, you write the brackets, okay? And I will do something very silly. I will do 0.1 times pi. Pi is the 3.1415, whatever. Do you remember that? In MATLAB, pi is that. So we say 0.1 times pi. Okay, I want to do this. Okay, 0.2 times pi. Can you do up to 1? Then I will copy this stuff here. Of course, this is completely inefficient, but it is good to start with inefficiencies first. So 0.2, 0.3, 0.4, 5, 7, 8, 9, and 1. Do you have this? Okay, so now, guys, what I want to do is I want to compute the sine function. So the MATLAB command is exactly the same as mathematics, the sine, the cosine, the tangent, etc. Okay, so the sine and evaluated in which values on x.
Just a slight error, I guess.
Oh, where?
You did 0.5 and then 0.
Oh, yeah,
So it might look different.
0.6. Yeah,
Yeah.
completely right. Yes, because the sine function is a zero function. So allow me to stop sharing this screen and allow me to go to the other screen. Yeah, the sine function, guys, you see my white screen, right? So the sine function, sine of x, this is what we call y. Wow, I'm terrible. So it starts here. When you go to pi, this goes from 1 to -1. And basically, it goes to 0. So pi over 2, it is like, sorry, it is like that. So when it's pi and a half, we go to 1. I don't know why I'm terrible drawing that. But that's the idea. This is the sine function. I will show you how to plot and all this stuff soon. Make sense? Okay. Easy, right? So you define the values, and then you use these values in a function, like we do in regular mathematics. Is this efficient or not? What do you think? Not efficient, right? Because if I tell you guys, you know what, I want you to go from 0 to 1 pi, but instead of increasing 0.1, I want you to increase at 0.01. So you're going to be typing 100 times the same number, so you're going to take at least 20 minutes to do this stuff. Doesn't make sense, right? Okay, so those are what we call sequences. Okay. Let me share my screen again, and let's start doing sequences. There are a couple of ways in which we can do sequences, okay? Let's define x1, it's another variable. And MATLAB understands sequences in the following order. So it goes, I want to go from 0, okay, to what? By increasing by what? By 0.1. This is my increase. And stop in pi is 2 dots here. So it is, this sequence, guys, goes from 0 by increasing 0.01 and the last value. Okay, you just enter, and you can see that the numbers are exactly the same. Oh, sorry, what I have done. 0, 0.1 to pi. Here we go. I have increased by 0.01. I want to be the same as before. This is what we had before. You understand the way that the sequences work? It is from increasing by what and the last number. Make sense to you? Okay, and then you can do your y1. Your y1 is going to be equal to the function sine of x1. What is going on here? Where is it? So my x1 goes from 0. Let me check this one here. Oh, no, I don't want that. I want 0.1 times pi. That's my increment. That's what I want to increment to pi. Yeah, that's what I want. It was good to see this one here also, because take a look. What I'm saying here is go from 0 to 0.1 to pi. Take a look. It doesn't, by adding 0.1, I don't go exactly to pi. Do you see? So it stops in the closer number to pi without violating the maximum restriction. Got it? But what I wanted to do was this one here, just to be as in the previous case. I want to go from 0, increasing by 0.1 times pi, up to pi. And these are the numbers that I get. And then I can do my y sine of x, and then we go exactly to what we had before. Questions?
So this sequencing is inclusive of both the 0 and the pi.
Yes, or normally the 0, yes, but the upper limit goes up to the point that is closer to this number, stops there, like here. Do you see? In this case, if I increase by 0.1, so it's going to be 0, 0.1, 0.2, 0.3. It doesn't go exactly to 3.1416. Do you agree?
Mhm.
So it will stop. This is the closest number that is below the 3.1416. Make sense to you?
Yeah.
So it will always include the first one for sure, but not necessarily the last one exactly.
Got it.
Make sense?
Yeah.
Okay, so let's play a little with this stuff here. Well, you can do different sequences. Okay, so let's create another one. Let's create X2. So you tell me what this one is doing. I want to go from 1. So what I'm doing here.
So it's just like adding 4. I mean, sorry, adding 3. So
Yes.
1, 4,
7,
yeah, etc.
etc.
1, 4, yeah.
They agree? Now, what I will do is the following. I will go. What am I doing there? Is this possible? Yeah, mathematically, yes. Because remember, MATLAB uses real numbers, so you can go to negative. You can do whatever you want. So this is start at 15, decrease by 3, and stop at 1 or closer to 1.
So, Professor Ngifa, will this read if you don't add minus to the 3? Like if it goes 15, 3, and 1, will it still read it?
You mean, you know what is beautiful about MATLAB is that no matter what you want, just test it. No.
Okay.
No. Okay. It needs to be logic. You cannot go from 15 to 1 unless you have a decreasing factor. Make sense? Okay, so this is the way of doing sequences. Now, there is another way of doing sequences, guys. That is called, let's call this X3. And the command that we're going to be using all the time is linspace. Linspace tells you, I want to go from 0 to pi. And what it allows you to do is how many observations do you want to have? MATLAB is going to do the calculations of instead of you calculating the intervals, MATLAB is going to do the exact calculation. So I want to have 10 observations. And take a look. It goes exactly, it starts exactly from 0. It ends up exactly at 3.14 and gives you the exact number of values. The interval, you don't need to compute anymore. You don't need to worry about that. MATLAB is going to do this for you. So this is the famous linspace. We're going to use linspace a lot. Okay, so just remember the linspace. Questions, guys? It's clear? Yep. Okay, so now let's go into array addressing. I want to know, so remember, MATLAB is let me stop this one here. MATLAB is a mathematical tool, do you agree? And as such, as a mathematical tool, MATLAB what does is the following. So let me, so what MATLAB does is always thinks in terms of a matrix, okay? Always. So what is a matrix? Well, let's start with a vector. Vector, we have a row vector. That looks like this, values and this. And then we have a column vector. Well, basically a column vector looks like this. And then we have a matrix. And the matrix, I want to tell you something. So we have n times m. N is number of rows, and m is number of columns. Okay, so how do we call this position here? So imagine, guys, that I have simply 4 observations. This one here is going to be row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So these are the notations. These are the positions of the variables. Make sense? And we have also something that are called arrays. So what is an array? It's a collection of matrices. So basically what I will have is I will have one matrix at the beginning, and then I will have a lot of matrices in the back. Okay, so again, number of rows, number of columns, number of faces. So your notation is going to be NMP. So this is the way MATLAB is going to define, and it's going to find information in an array. So for example, if I say 1, 2, 2, how do you read this one here? Give me the information in row number 1, column number 2, the second matrix. So what it will do is it will select row number 1, column number 2, so one second column, but not from this screen, from this matrix. It will select the second one. Make sense? Okay, so let's start working with MATLAB. So how MATLAB defines these things, and we're going to play a lot with this stuff. So let me stop sharing here. And let me move this here. Okay, so let's start. The way I define a matrix, a vector. So if I want to define a column vector, guys, simply remember a vector is with a brackets. So let's do 1, 2, 3, 4, and 5. So you can take a look. This is my row vector. If you want to write a column vector, I will call this V. Okay, and let's call back A, and I will call this V. So if you want to write rows, so what you do is you do semicolon. After each number, you do semicolon. Later, we're going to use the transpose and all this type of commands. But at this point, this is the way it works. Make sense to you? And let's define a variable D or ABC. So, and I will do a matrix. Let's say a 3 by 3. I will do 1, 2, 3. This is my first column. My second column, sorry, my first row, my second row, and my third row. Oh, yes, of course. Okay. Do you have the same 1, 2, 3, 4, 5, 6, 7, 8, and 9? This is a 3 by 3 matrix. Correct?
Yeah. If you put commas after the numbers,
No
that doesn't
problem.
change anything?
That's okay. No.
Okay.
So you can do
Just
this, or you
implied.
can do, yeah, exactly. So
Okay.
they don't change anything. Just take a look. Okay. The space or comma. But if you want to put this in the second row, you need to use the semicolon. Okay, guys. So how do I identify? I want you to select these 5. So I want D to be equals to these 5. You see, so what I want is I want to extract one particular value of C and put it into D. So this is going to be D is going to be C, and that's the way you address one array. So, okay, from C, what position do you want from C? Guys, what position do I want from C? 2, sorry, 2, 2, yes or no? Position 2, 2 is this 5 here. Second row, second column. Okay? So now I want D1 to be the third column of C. All the elements of the third column of C. So it's going to be, I want from C, you select from C, all rows. This is the way you write all rows. And my third column. Make sense to you? Okay, guys, I want D2 to be this part here, the 5, 6, 8, and 9. I want the 5, 6, 8, and 9. Well, this is going to be C. You tell me what I write here.
Is it gonna
Yes. I miss you.
sorry, 2:3 for rows and then
2,
2:3 for
column
columns.
3.
Yeah.
So this is rows 2 to 3,
Yeah,
comma, and also columns 2 to 3.
3, yeah.
Make sense to everyone?
Yeah, I have a question, but I don't want to get other
Yeah.
people confused. But basically, if C were to change, would D1, D2, would this all change? Like, is it pointing to it or?
Yeah, it will. Not in this workings command window, but when we have the program, yes.
Okay.
Okay, yes, definitely. So if you have a matrix, and that's also good, right? Because that's what you want. I have data, IBM, Tesla, etc. And then you change the data, you want the program to continue working. Makes sense? So these D1, D2, D3, whatever you want, that are calling a matrix. In this case, I'm calling the matrix C. It doesn't matter what data do you have inside. Okay? Makes sense to everyone? Okay, so now what I want from you guys is the following. I go back to my C. So let me type my C again. So what I want is the following. I want the matrix C, but I want the last column of C, so this one here, 3, 6, and 9, to be the first column of D3. So I want the last column of C to be the first column of D3.
But do you want anything else in D3 or just?
No, no. So it's going to be a 3 by 3 also.
Okay, okay.
But the third column, I want this to be the first column. So what I do? You tell me, guys. A lot of ways of doing this stuff, but one of them is I want to take all the rows. The only thing that I want to shift is the columns. Make sense? And what I can do is the following. I can tell MATLAB in a vector form the order of the vectors. So I want this to be 3, 1, 2. Do you see that? It tells MATLAB all rows, but the order of the columns is going to be the third column, then the first one, then the second one. Make sense? Okay, now what I want from you guys is the following. I want you to shift the columns. So I want column 3 to be column 1, column 2 to be column 2, and column 1 to be column 3. So basically, it's like having your matrix in this way shifted completely. The last column, the middle column, and the first column. Try to use the sequence technique. So let's call this D4.
Professor Ngifo, I don't know if I
Yes.
did it correctly. What I did was the same thing, but I did the 312 first, and then I added the colon in the end, and it reversed the columns for me.
Oh, so you're talking about D4 already?
Yeah, so
Yeah,
for
okay. So
D4.
tell me what you have done. See what I type.
So it's D4 equals C,
Yeah.
parenthesis, vector 312,
Oh,
comma,
yeah. Vector.
colon. Oh yeah,
Sorry.
vector 3 and then 1 and then 2.
3, 1, and 2.
Vector again, comma, colon.
Yeah.
Oh no, just a colon, not vector.
Oh, yeah. Oh, this one.
Yeah.
Okay. So what do you think about these guys? What we are changing here?
Does this order the rows differently, or am I
Yeah, here what we are
mistaken?
ordering is the rows. So our matrix basically shifting this way with this one here. Do you agree? So my third row is going to be my first row, the second, and the first is going to be the last one.
Yeah,
What
that's
is
how
it?
the page for me did it.
Okay, so what is this one here, guys? Take a look to see, and let's run this one here. So I have 7, 1, 4. So I shifted the order of the rows. So it goes the third one first. Where is this one here? My third row, third 1, 2. Okay, so what I've done is the third 1, 2, 7, 1, 4. But the components of the columns are the same. Right? All my columns. So we have changed the 3 is 9, 3, 6. 9, 3, 6 is here. Then I have my 1. Yeah, but this is not what I want at this point. So what I want is basically the following. Allow me to share my screen. Allow me to share my screen again. So what I want is the following, guys. D4, C equals 1, 2, no, sorry, 1, 2, 3, 4, 5, 6,
If you
7, 8, 9. I'm sorry, I'm not showing my screen.
no, you're not.
Oh
Yeah.
yeah, I'm not. Sorry. Yeah, do you see my screen now? Guys, you see? Okay, so this is my C. So what I want from D3 is the following, or D4. I want D4 to be 3, 6, 9, 2, 5, 8, 1, 4, 7. So what I have done is I have moved all this column to the first one, second column stays, and the third column goes here. Make sense? And just to be sure that you understand what I'm trying to tell you, I want D to be 7, 8, 9, 4, 5, 6, 1, 2, 3. So basically what I'm doing, this one here, this shift here is like doing my matrix this way. Do you agree? The original C moving like this way. And this one here is basically moving my C this way. Here, moving. Okay, 2 minutes to do this stuff. Ready? So let me stop sharing the screen and let's go up to MATLAB. Okay, so let me call back again my matrix C. This is my C, right? So what I want D3 to be is basically I want to shift the columns. I want to do this with my matrix. So it's going to be C. Do I need to do anything with the rows? No, the rows are going to be exactly the same. But I need to shift the number of columns. So I want the third to be the first, the second to be the second, and the first to be the third. How can I do that? Of course, you can do brute force, guys. These 3, 2, 1. They agree? Makes sense to you or not? It will work. But the thing is that if you have a matrix that has hundreds of columns, it's going to be a pain in the neck trying to do this stuff. Okay. This works when you have exact changes. So I want this column, the fourth column, to be the first one. For example, name sometimes appears in the middle of the matrix. I want the name to appear in the first one. So this technique here works very nicely for that. But if you want to do a complete rotation of matrices, it's better to do the following. You tell me what I'm doing here. I'm doing 3. What is this 3 minus 1 to 1 is going to create? What is the sequence? 3, the next one, 2, the next one, 1. Is that what we want?
Yeah.
Yeah.
Does it have to be in brackets?
No. When you have sequencing in the vector, it absorbs that. If you put brackets, no issue. But if you put numbers, in that case, you need to put the brackets to tell MATLAB, hey, this is a vector. But if it's a sequence, for definition, MATLAB assumes this is a vector. Make sense?
Mhm.
Here we go.
Sorry, can you hear me?
Yes, Lauren.
Okay, so I just want to make sure the I'm just kind of confused which is D4 again, and can you just
Oh.
walk through what you've typed in for D3? Yeah, sorry.
D3, D3 is, let me go back again to what is D4?
The one you had just written. Yeah, D4
Yeah,
and then what
well,
you had just
yeah, this should have been D4. This should have been D4. You know, I just messed up with the numbers. This is my D4. So my D4 is this one here. Allow me. Yeah, I will be moving this way. This is D4. You see my screen?
Yes. So just to make sure, you essentially just want to flip.
I have
We're
flipped.
keeping
This
the
goes here.
contents.
Oh, yeah. Keep the rows.
Okay, we're
The
keeping
only
the
thing that
rows.
I
Got
have
it.
done is change the columns.
Okay.
Okay?
Mhm.
It's basically you
you.
have your matrix this way. What you're doing is moving this way. Okay? This is one possible rotation this way. Now, another possible rotation is this is your matrix. You rotate this way. So what you want is the third row to be the first row, the second row to be the second row, and the first row to be the third row. Okay?
Got it. Thank you.
This is my D5. So you see now, guys, how can you do the D5 now? So D5 is going to be equal to what? In this case, what I want to shift is the rows. So where's this one here? These are my rows, and I want to keep all my columns. Correct?
Professor,
Yes.
I just had a
Karina.
question. For what does the -1 represent or the -1?
Oh, it's simply the sequence. So remember the sequence goes from increasing or decreasing by
Okay.
up to the number. So this implies start at 3, decrease by 1, and stop at 1. So it's going to be 3, 2, and 1.
Okay.
Make sense?
Yes, thank you.
Perfect. Now, guys, the other thing that we need to be sure is how to append vectors to matrices, etc. So let's define D6, and you just write D6, guys, as let's do 888. But I want this to be a column vector. So what I want to do now, guys, is to create a D5 or D6 or what is that? No, D6. Simply that is going to be equal to C, and I want to put next to C this D column. So now it's going to be a 3 times 4. Got it? So this is D6 equals, I need to tell MATLAB that I want to append 2 matrices. And what I want to append is C with D. So that's extremely easy. If you have 2 matrices, you want to put them together, you have 2 data sets, you want to put them together, you simply do this stuff. Do you see what I have done? Just put this in the vision, guys. I always like to do small examples, but you can have this. If you have hundreds of rows, hundreds of columns, it's exactly the same. Exactly the same. Questions? Can you create another, let's call it, I'm terrible with names, F. So now F is going to be 7, 7, 7, 7, but it's going to be, it's 4. Can I join C, that is a 3 by 3, with this C, with this F? Let's call this D7. It's going to be equal to C and F.
Can it be for the fourth row that we don't have? That's all going to be zeros, or we can't do it at all?
Yeah, take a look to what happens. MATLAB is going to tell you, you cannot do that. Okay, and then this is good because you know what? Sometimes we don't know. I will show you how to do this stuff later, but there are ways in which you can append this type of things. You need to add zeros. You need to add another thing to make them conformable. But a priori, if you have that this one here has 4 rows, this has 3 rows, we cannot join them. Okay, make sense? Okay, so let's do some scalar array mathematics, guys. So let's define A, very simple numbers. and let's define B. Okay, so what is called scalar array mathematics, guys, is what we call one by one, element by element operation. So if I want to say, for example, A plus B, what it will do is what? It will take the first element of A, first element of B, and then simply sums. Do you see? 1 plus 5 is 6, 2 plus 6 is 8, etc. Now, sum and subtraction is exactly the same, no issue. But if you want to do one by one multiplication, so what I want to do is, I want to multiply this by this. When you just write the star, MATLAB is going to understand that this is satisfying the rules of matrix multiplication. And of course, A and B, like they are, they don't satisfy that matrix multiplication rule. So we're going to have an issue here. But I don't want to do that. I want to do element by element multiplication. So in order to tell MATLAB, so let me talk again about A and B. So I just want element by element multiplication. When you want to do that, guys, you need to do the element by element multiplication is dot star. If you do that, it's doing one by one. 1 times 5 is 5, 2 times 6 is 12, etc. I can do also the power. So the things that are common are the power. So the dot, star, dot, the hat, see, this implies simply element by element operations. Okay, so let me go back into A and let me go back into B. So what do I need to do with B in order to make this able to do a matrix multiplication? So what I can do is I can transpose B, right? Okay, how do we transpose in MATLAB? So let's call this B1, and the transpose is simply the apostrophe. Okay, so B1 equals the transpose of B. So here we go. Can I now multiply A times B1? Yes, I can do that. A times B1. So A equals a what? A equals a 4 times 1. Do you agree? So let me stop sharing and sharing my other screen. So I have A equals 1, 2, 3, 4. So A equals 1 times 4. And B1 equals, I think it's 5, 6, 7, 8. So this one here is 4 times.
Are you share? Do you want to share the white screen?
Oh, yeah. Sorry for that. Yeah. Yeah.
Thank you.
You have A. A is 1, 2, 3, 4. It's a 1 times 4. 1 row, 4 columns. And B is going to be 4 rows, 1 column. Can I multiply A times B1? Yes, because this is a 1 times 4. And this one here is a 4 times 1. So what is your resulting vector C? Is going to be a what?
1 by 1?
It's going to be a 1 by 1 that is called a scalar. So this is the famous scalar multiplication. So all this one here is called a scalar multiplication. Make sense? Okay, so okay, you do that and you tell me what is the number that you get. And then I give you the following. Define a variable u that is equal to 3, 2, 4, 5, and 7. And I want you to find the sum of u squared using matrices. Well, in this case, using vectors.
Professor, just so you know, in the MATLAB version of B1, you did 5, 6, 7, and then 9, I believe.
Oh,
Unless I
yeah.
misread that. Yeah.
Yeah, yes. Yes, the number that you have in here in Excel. Yeah. Should be 6, 7, 8. Yeah, I omit this one. I put this 9, right? Yeah. Ready, guys? Okay, why this one here is, let me resume recording. Why this one here is so famous, guys? Do you remember when we do the ordinary least squares, what is the criteria? We try to minimize the sum of square of the errors, do you agree? So basically, this is the criteria. Okay, so mathematically, guys, this is the sum of a square of the errors is a scalar, right? So the resulting value is a scalar. So I want a 1 by 1. So what I will do is, what if I do u times u prime? U is going to be a 1 times 5, and this is going to be a 5 times 1. So the resulting value is going to be a 1 times 1. Correct? So what we are doing here is, okay, this is my mu, 3, 2, 4, 5, 7. That multiplies u prime, 3, 2, 4, 5, and 7. So if you do this mathematical operation, guys, it's going to be 3 times 3, 3 squared, plus 2 times 2, 2 squared, plus 4 squared, plus 5 squared, plus 7 squared. That is exactly the same as... Make sense? Okay. So let me do this. Let me show you my screen again into MATLAB. So let's talk first about C. I said that this was going to be C. So everyone got 74? We got 74?
Yes.
Yeah.
Okay, so then we define U is going to be a vector that was equal to 3, 2, 4, 5, 7. And what I can do is I can simply write U times U prime. That's all what it needs. Correct? You can name it if you want. Okay. Make sense to you guys? So I think I call C. I cannot call my matrix C again. Can we call back again this one here? I think I overwrote this one here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This was my original C matrix. Okay, just let's call this back. There are a couple of commands, guys, that are going to help us a lot. One of them is called the size. Size of C provides me the first element is number of rows, second element, number of columns. Okay. Now, if I just want the number of rows, size C, comma 1 is number of rows. If you want number of columns, C, comma 2. Now, if you want to know what is the maximum dimension, well, in this case, it's a 3 by 3. Okay, but if you want to know which one is the maximum dimension, what you do is length. So this, if it was, imagine a 10 times 3, the length is going to give you the maximum, 10.
Sorry, Professor, I'm just confused. Why did you do C2, size C2? I know that C is
2?
representing columns.
Yeah, the 2 is columns. No. The C is the matrix. C is
Yeah.
this matrix.
Oh, okay.
So when I do size 2, this 2 represents columns. If I
Oh,
write
okay.
1, rows.
That's rows. Got it.
Exactly.
Thank you.
Make sense?
Perfect. Yes. And then length is just
The maximum number of observations. So let's define, for example, my computer is very old. It doesn't accept. The escape is broken, so I need to change computer. So let's do C equals C. Sorry, and I will add to this one here. Where's my? What I'm doing there is what, guys? Then I will call this C1, just not to destroy my C1. Do you see that? So C prime or C1 is going to be equal to matrix C, and next to it, a column of 8s. I define the 8s here as a row, but I have to use the transpose. So the 8s transpose going this way. So now let's do length of C1. Now, see that?
Is there any way to know that if the length returned the row or the column?
In that case, you use size.
Okay, yeah.
Yeah, there is no way. You know that. Well, normally when you have your data set, you know which one. And normally the number of rows are larger than the number of columns. But if you really don't know which one, use size. Okay?
Wait, everything you can you explain why you added the prime or the apostrophe after the 8s
Oh,
in
yeah.
C1?
So this one here creates a vector, a row vector. Do you agree?
Yep.
So if I do, this is a 3 by 3, and I want to add a row vector, I cannot add. You need to move it as a column.
Okay.
So that's why you need to have this one here. So the row, put it in a column, and then you can join them together. Got it?
Okay. Yep. Later.
Okay. So now let's go into a little detail. Okay, let me show you something. I think I have one Excel here. Do you remember demand functions, guys? Do you remember that? So I have quantities in here. Let me talk a little about demand functions. Give me 1 second. So before going here, let me go into demand functions for 1 second. Let me save this one second. Yeah. So let's go back a little in here. Yeah. So remember, guys, that you are seeing my white screen, right? Let's talk a little about demand functions. So a demand function, guys, in economics is drawn like this. I have Q, quantities, and I have, what is my cursor? Here we go. And I have prices here. So the demand function is a function that looks by the law of demand. The higher the price, the lower the quantity. Or the lower the price, the higher the quantity. So basically, let's assume that look like this. Got it? This is my demand function. Now, how my demand function, what is the equation of my demand function? If we assume that it's a linear demand function. Okay, so in general, guys, a linear equation, in general, a linear equation is y equals a plus b x. Do you agree? So how do we call a? This is the famous y-intercept. And what is b?
Slope.
The slope. In this case, my slope is going to be positive or negative? Negative. Does it make sense? So one of the examples that we're going to be working in a minute, guys, I'm going to tell you, draw this line. So let's assume that my A equals 10 and my B equals minus 0.5. Okay, and the interval of values for x is going to belong to, so sorry, x for me is q, right? So y for me is going to be, y is going to be my p and x is going to be my q. So q belongs to 0, 20. So what I want from you guys is create a variable called q, do a sequence, a 0 up to 20, just increasing by 1. And then I want you to tell me what is I want you to create this p that is going to be equal to 10 minus 0.5 of q. Create this equation here. Okay, first let's do that in MATLAB. So first you need to define your q between 0 and 20. So it can be 0, 1, 2, 3, 4, 5 up to 20. And then you compute your p based on the formula.
Quick question. Since this is quantities, right? The increments between 0 and 20 should be just 1, right?
Yeah, increase it by 1, 0, 1, 2, 3, etc. 2 minutes to do this, guys.
Hmm.
It's just to create the line. Alfredo?
Yeah, I was gonna say, I don't know if I got it right, but when I tried doing it, it showed 10 to 0 going down in 0.5 increments, but I'm
No,
not sure
no.
if that's
Have you written Q equals 0 dots,
yeah,
1
and then it
dots,
gave me
20?
0 to 20. Yeah, it gave me 0 to 20 in order, and then I did the formula 10 minus 0.5 times Q.
Yes?
And then yeah, it showed me from 10 to 0 and it went down by 0.5. So it's 10, 9.5, 9.
No, it can be. Yeah, it can be. It can definitely be. So let's take a look to that. Yeah, it can definitely be because you're creating basically, you're gonna see this in let's take a look to stop sharing this stuff. Let me go back. Okay, so what we are drawing, guys, is this one here, the 20, it goes from 20, the blue one, okay? It's this equation here. Let's take a look in MATLAB. There are a couple of things that you need to understand about this stuff, but here we go, a little application on economics and how elasticities are measured, okay? That people confuses elasticities all the time. So let's go for Q. Q is going to be equal to 1 to 1 to 20. We said that, right? Oh no, 0. Make sense? And what I want is I want to have this one here, and I want to transpose this one here. So I want to have this as a column vector. It doesn't affect the estimations. Okay, I have Q. Now what I want is I want to compute P, and P is going to be equal to 10 minus 0.5 times Q. Correct? And this is what I have. Do you know why I have put this in a vector form? Because I knew that this was going to come into vector form. So now I want to create PQ as a single matrix containing both. So it's going to be Q and P. I think I called Q and P, right? Yeah, Q and P. Do you see what we have? When Q is 0, well, it should be called Q and P. When Q is 0, P is 10, etc. Of course, guys, one way of seeing this one here is plot. So let's plot. Plot goes X first and Q and Y later. So in this case, X is Q and P. So a very simple plot. Let's do our first plot. Here we go. So this is my demand function. Easy or not? Yeah, later we're going to see real data, and then we're going to feed the line. You're going to see how easy is this one here. But it makes sense to everyone?
Professor,
Yes.
why do we transpose?
Oh,
Q.
because I wanted to create this table here. And I knew that this operation here, P10 minus this one was going to create a vector, a column, a column vector.
Okay.
Because I've done this before, so that's why I knew it. Otherwise, what you do is you have the P is going to be a row, and your Q, if it's a row, your P is going to be a row. And then you can transpose. Okay? Okay, guys. So let me go back to I want you to prove the following. So let me stop sharing this one here. And let me go to where's here. Let me share again this one here. You see my screen? You see my screen? Okay, guys. The elasticity, how do you define elasticities?
Is it like the slope?
Elasticity demand. Aha. The elasticity demand, let's call this E. Is the elasticity equal to the slope? First question. Is elasticity equal to the slope? If it's true, remember that the slope of the line is always constant. So this implies that the elasticity should be 1. So if you have, it should be one value, it doesn't change. Is this true? And let me tell you guys, you're not the only ones that confuse this one here. The answer is no. They are not the same. Second question for you. Is elasticity constant across that demand function?
No, it's not.
No, it is not. Okay, so what I want from you, how do you define the elasticity? Okay, let's define elasticity simply as percentage change on Q divided by percentage change of P. So in words, guys, this is Q1 minus, let's say, Q0 over Q0 over P1 minus P0 over P0. So this is my demand function. Sorry, this is my elasticity. Where is my table? Okay, guys, so what I want from you, give me 1 second, please. Yeah, what I want from you, guys, allow me 1 minute, okay? 1 minute. Continue working on this stuff. I just need to see something. 1 minute. Francisco, la puerta. Sus amigos. ¿Están viendo qué? No, sus amigos. Okay, guys. What I was going to do. Okay, so do you remember you have the matrix? So let me go back into your MATLAB. Okay, can you add, you know what, here I don't know the number of rows. Can you add the first column to be number of rows? You see what I'm telling to you? So your PQ, no, not this one. This PQ, I want the first row, sorry, the first column to be the number of rows. So 1, 2, 3, 4, 5. How do you do that? Tell me if I'm right. 1, 2, n. Well, I can do this. Size of Q, comma 1. What do you think about that? This is going to be a sequence that goes from 1 to size of Q1, Q and P.
But
Other-
you don't have to put the step
Now, remember, if you don't put the step,
It
by
just
default is 1.
okay, yeah.
Okay, that's the only one. If the default is 1, you don't need to put the step.
So
Make
essentially
sense?
what you just did is just to label this as first observation, second, third.
Exactly,
Okay,
exactly
thank you.
that. Exactly that. Because I want to give you something here. Okay, I want you guys to compute the elasticity. So now let me go back and I will give you 3 minutes to do this stuff. I want you to do the following. Okay, just to show me that this is not true. Let me go back into, yeah, so compute the elasticity between observations 2 and 3, and compute the elasticity between the observations 18 and 19. Okay? Okay, 3 minutes to do this stuff, guys. Allow me to drink some water. ¿Qué pasa? No, no. Okay, done? So we want the elasticity at point 2.3, sorry, using points 2 and 3. Which one is my P and which one is my Q? Q is this one here, right? The second column. So I want this minus this over this minus this over this.
Cuando tienes tiempo, puedes cargar mi teléfono nomás. Porque no sé si vamos a salir un ratito más tarde.
No salía, está jodido.
Sí, pero no sé si vamos.
Okay, guys. So let's take a look to let me stop sharing. Let's do the MATLAB. So what we want is to estimate the elasticity between points 2 and 3, correct? Using the data here. Agree? Okay, so which one is P? I need to be sure which one is. So this is Q and this is P. That's the only thing that we need to know. Okay, so let's call it elasticity point 2 and 3. So it's going to be, let's write the formula. It's going to be my matrix PQ. What is Q, Q, Q? I call it matrix PQ. What position? It's going to be third row, second column, minus matrix PQ between 1 2 and 3. Oh, sorry. Yeah, it's good. Minus PQ of position 2 and 2 divided by, then we put the parentheses PQ position 2 and 2. So this is the first part. Do you agree with me, guys, or not?
Yeah, that's the
Okay,
top.
that's the top. So I need to do the same. So I will do another parenthesis. I need to do the same. I need to divide this by basically the same, but in terms of prices, correct? And in terms of prices, the column is number 3. That's the only thing that it changes. Agree with this formula, guys? So what is your elasticity? Upside. Oh, yeah, of course. This is parenthesis. What is not like? Let me check. Yes, that's what I mean. PQ minus.
It's because you copied it, so there's another curly.
Yeah, where is my curly? Where's my curly? Here we go with this one here. Minus 19. Do you get this number? We should get the same number if we have done the same mathematics, guys. So let me call back the PQ. So this is my PQ. And the formula I'm using is this one here. I want the elasticity between points 3 and 2, or 2 and 3. So it's going to be 2 minus 1 divided by 1. So this is 1. So if we do this by hand, And the other one is 9 minus 9.05 over 9. So it's 0.5 divided by 95. So 0.5, 0.052. Yeah, 19. Negative 19. Guys, you must have this number. Do you have this number? Minus 19.
Yes.
Okay? Trevor, Alfredo, Karina, Ofama. Perfect. Okay, now we are using the same equation, the exact same equation. And what we are doing, guys, what we have done is we have computed the elasticity around this part here. Correct? When Q equals 1, I think, or 2. So we have computed the elasticity here. Now, let's compute the elasticity in 1819. So basically, in this part here. So the formula is going to be very similar, right? But let's call this one elasticity 1819, or yeah, we can call it. This is simply names, guys. 1819 is going to be position 19. Position 19 with position 18 over position 18. Position 19, I'm sorry, 19, position 18 of the prices, position 18. So what do you get? Minus 0.17. Makes sense to you guys or not? Where's my graph? What I want from you guys is not only the math, but also the intuition and the logic. Does this make sense to you? So as an economist, guys, this is one of the things that you're going to be facing all the time. Okay, first thing is that the economists try to confuse elasticity with a slope. No, they are not the same. They are related, but they are not the same. Got it? The second confusion is that elasticity is constant across a demand function. That's completely wrong. The elasticity changes according to the relative position of prices. So what is the meaning of minus 19 here, guys? What is this minus 19 means? If there is a unit price increase, what is going to happen with my units?
Would decrease by 19 units.
It's going to decrease by 19. It's very strong. Do you agree? And this happens when the price is already very high. So this tells you if you have a client and your client is already in the upper side of prices and he wants to increase the prices, you know what? It can collapse his business. Make sense? The elasticity is extremely strong. It's going to destroy the business. But now, if you are in the lower spectrum of prices, an elasticity of 0.17 gives you room for increasing prices or not? Definitely. Yeah, increased. Nothing is going to happen. 0.17. It's okay. Because you are already in the cheapest products. Makes sense to everyone? Okay, so you know how to, we are going to do empirical analysis later. What I will do is I will give you points, observations, and then you're going to be able to compute the line. And then once you compute the line, you are going to be able to compute elasticities, etc. And then make recommendations about, okay, do I increase my price or I decrease my price? Because in this case, guys, what is the best strategy for you is decrease the prices. Do you agree? So if you are very close to the top of the demand function, better decrease the prices. Why? Because the increase on quantity is going to be huge. Make sense to everyone? Okay, do you understand the MATLAB code? Excellent. Okay, so now can you open please your Word document? I gave you class 1 something. You're gonna work. Yeah, I want you to work with all this part here. 7 questions, maximum, let's say 10 minutes. So you have the data here, sugar, rice, these are the quantities and these are the prices. What I want, first of all, I want you to put this information in a matrix that you're gonna call Z. Kilos in the first column, what is that? Prices, quantities in the first column, prices in the second column. Sugar first, rice second, flour third. Then I want you to find the number of columns, the number of rows, the total number of kilos, how many kilos are we buying? I want you to create Y1. So it's going to be a row vector with only kilos, quantities. Y2 is going to be a vector of only prices, row vector. And I want you to change here basically flour goes first, rice second, etc. Y4 is going to be kilos times prices, etc. Up to here, 6 and 7. Make sense to you? 10 minutes, and then we solve it. Let me pause the. Okay, go ahead, guys. And allow me 1 minute again. So I'm talking about this part here, right? How are we doing, guys? 1, 2, 3, 4. Where are you?
Finished 5.
Okay, perfect.
I'm just
Four-
trying to sum the kilos right now.
Okay, go ahead for that.
Yeah, I'm
So,
on 4.
perfect. Four more minutes, okay? What is important for me, guys, is that you get used to these type of things. That would be complicating our lives soon, but easy thing first. Okay, 1 more minute. Okay, so let me move this somewhere so I can be working on my matrix, okay? So I will create. So I want quantities, okay, so I want. Agree? So my vector Z, quantities and prices. Yep. Now what I want is number of columns. Okay, very easy. Size, size of Z, size of Z, what columns is equals what? 2. So I have 2 columns. Number of rows, the same, but with 1. 3 rows. Total number of kilos. What I can do is I simply can sum Z, everything, comma 1. No, sorry. Everything, comma 1. Kilos are in the first one, correct? So we have a new command here, sum. 12 kilos. Okay, so guys, I'm introducing a small language. Sum is a new command that we have. Then I have y1 is going to be only kilos. So this is going to be Z, everything, comma 1. But I want this transposed, correct? Because I want this to be a row. Then Y2 only price. Oh, sorry, this is kilos, is correct. Only prices is going to be Z2. Sorry, I want to keep Y1 and this is Y2. Y3 is going to be kilos prices. The only thing is that I'm shifting the matrix this way, correct? Okay, so what I can do, this is called Y3. Y3 is going to be equal to Z. I'm changing the row, so it's going to be 3 minus 1 to 1, all columns, correct? Okay, allow me 1 minute to tell you one additional column, one additional program, command. Let's call this A. That is called flip up and down the... So instead of doing this stuff, guys, there is a special command that is called flip up and down. Okay, so we can do this manually. We know how to do that. But if you want to use a MATLAB command, the command is flip up and down. Got it?
So is there the same flip left, right?
Yeah, exactly. There is another one that is called flip left, right. Okay. So I have my Y3, then I have kilos times prices. Y4 equals kilos times prices. Can I use Y2 and Y3? No, sorry, Y1 and Y2. Y1 is this one, Y2 is this one. Can I use that?
You need to transpose one of them. Well,
Not
so the
necessarily.
dimensions? Really?
No,
Oh, okay.
no. Remember, it's 1 by 1. So if you see the structure of Y1, this is the quantity of sugar, the price of sugar, quantity of rice, price of rice. So what you want is this times this, plus this times this, plus this times this. You agree?
Yeah.
So
The thing is,
yeah.
sorry. I was gonna ask, is that one the Y1 period times Y2?
Yes, Y1, and there is one more thing, right? Y1 period, Y2. So what this is going to do is going to have a new vector, correct? Multiplied 1 by 1. But what I want is what? What else is needed after that? Because what we are asking here is the kilos times prices. Oh, yeah, well, that's I think it's okay. This is kilos times prices.
Mm-hmm.
And then the Y5, what is that? Oh, yeah, it's the sum. Y5 equals sum of Y4. So what is this, guys? Is my total price, my total cost. Correct? So instead of doing this one here, guys, I can do this directly. I can do the same. I will call this Y4A. It is the same. So what I do is I do element by element multiplication. So if I do element by element multiplication, I get this part here, correct? Then if I sum, I get this one here. So instead of doing 2 steps, I can do this in a single step. And so that's what is called in MATLAB compounding. So you need to do a lot of steps. You can do in a single step, you can put a lot of functions. First, do the element by element multiplication, then sum, then boom, boom, boom. You build in a single line. Looks like German that you can build up with a language.
Quick question. Can you explain why again we don't need to do the transpose here?
Where?
In the Y4. Like, why is it?
Oh,
Because we had the,
because
yeah.
y1 is
Mhm.
like a raw vector. Y2 is
Mhm.
also a raw vector.
Mhm.
And so what we want is this is sugar, this is sugar. Do you agree?
Yeah.
So element by element is this times this times this times this.
Okay.
Oh yeah, I understand what you're saying. You can go
Yeah,
directly
yeah.
also, you can go directly to this one here
Mhm.
by transposing one of them. So you can do
Yeah, yeah,
y1,
yeah.
y1 times y2. In
Y2.
that case, it's
Yeah.
going to be the multiplication and the sum at the same time.
Got it.
Completely
Okay. So
right.
it's possible. Okay.
Oh yeah,
Thank
yeah,
you.
yeah. So let's do y4b equals y1 times y2 transpose. It's also possible. That's algebra. That's sort of linear algebra. Makes perfect sense. Do you agree, guys? Which one is more efficient, guys? So we have three ways of doing the same stuff. First, I do element by element multiplication, then I sum, then I obtain my 430. Or I can do the same in a single round, or I do the matrix one. Which one is more efficient?
I personally would pick Y4B. That's just me.
This one here.
Yeah.
So remember, guys, that we don't see that these are so small numbers and my rows are nothing. But when we have real serious research, guys, all the time try to do matrix. Matrices are the most efficient way of doing some programming. Do you agree with that? Well, not always you are going to be able to do matrices, but if you can, do it. It saves a lot of time, a lot of memory. It saves a lot of things. Make sense to you?
Yeah. Sir, you had a question
Yeah.
for Y4B. I tried testing it out and I got 9 different numbers out of it. I'm not sure if I did anything wrong with that.
In here,
Yeah,
this one?
in that one. Yep.
Okay, so you need to verify first that y1 is this one.
Mhm.
Just type
Oh, I
y1.
didn't make it into a row yet. Would that affect it?
Yeah, definitely.
Yeah, okay, that's why.
Definitely. Yeah. Here,
Okay.
remember, guys, when I started doing programming, it took me almost 3 hours finding a mistake. And I was getting a completely disaster. It was really a disaster. After 3 hours, I found that the mistake was an apostrophe. There was a transpose. Okay, and I was blaming the program. And at the time I was using, what program was that? I think Gauss. Gauss, you haven't heard about Gauss, but Gauss is a very good program, but it's very, very old. But it took me 3 hours to find that the mistake was a simple apostrophe. So the program doesn't fail, it's us that fail. Okay, we make the mistakes. Make sense to everyone? Okay, I think that we have everything, right? Oh yeah. How do we delete one row? So let me call again. What was my main matrix? Z. Well, yes, I want to delete one column. So let's call this C1. Delete, guys. Delete the first column. How do you do that? Sorry. Well, C1, if you want to delete one column, is simply Z everything, comma 2, right? This is one way of deleting that. But there is a way in which I want to delete this one here. Z everything, comma 1 equals this one.
Yeah, that's right.
Okay? The difference, guys, is that I have destroyed now my C. Because now my C, if you take a look to what is C, C is only one. I deleted technically the first column. So that's why if I don't have huge matrices, what I prefer to do is I prefer to create a clone like this one. Got it? And then you keep the original C. Now, this works when you have small data sets. When you have huge data sets that we used to have in a stock market, for example, this is impossible because your memory is going to be packed. If you keep two data sets that are exactly the same, but one with a couple of columns less, you have double data sets. So normally what you do is you do the second strategy, this one here. You simply put out. Make sense to you?
Wait, just to make sure we're deleting the first
Column.
column?
No,
Okay, 'cause-
no, sorry. It's the first column. You see that? Is
Yeah.
all rows, first column equals empty.
Okay. Got it.
It's logic, guys. You see that? Everything is purely logic in MATLAB. Okay, so now let's go, and I would like to talk a little about, we have the 3D arrays. Can you check your Word? You have something that says 3D arrays. Can you please copy these two guys? Oh, okay, so let me tell you, first of all, what is a 3D array? So in this case, we have 5 years, 3 individuals. The first phase, the first matrix is going to be income. And the second matrix on the back of that is going to be savings. So we have an array that is going to be 5 times 3 times 2. Make sense to everyone? 5 rows, 3 individuals, 2 pieces of information, income and savings. So this is the piece of information. Can you copy this into MATLAB, please? Oh, what I've done. Yeah, that's okay. So panel data 5 times 3 times 2. Do you see this one here? Okay, guys.
Gifo. When I tried
Yes.
copying it, it shows our error using VertCat. I'm not sure if I copy wrong.
We're using, where is my, this one here, panel data in the Word document that I sent you today.
Yeah, when I copied it, it shows VertCat error for some reason.
Wait,
I got
can you copy this again? And let me show you. Can you copy this again? I'm sorry, not this one. No. Can you copy just this part here? So this says all columns, all rows, first phase. These are the values. All rows, all columns, second phase, all these values. Can you check that, please?
I get the same error, Professor. It says error vertcat.
Okay, can someone show me? Okay, can you show me your screens, please?
Sure, I can be the one to do it.
Yeah. Yes, share. Yeah.
Yeah.
Yep, you can.
Sorry, I tried it multiple times, but
Okay, wait. Yep. Okay,
yeah.
wait a second. Panel data 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, yeah. Perhaps it's because, yeah. Can you go to the Word document for a minute? Okay, copy that one, but don't, yeah, copy. Just go, not only that one. Yeah, okay. Control C, go to MATLAB, and don't press enter. Just copy there. Yeah, okay. Now can you go to 89,000?
Okay.
Yeah, at the end. Go at the end. Yeah, can you delete one space?
I delete the 0 at the end.
18. Oh, you delete. No. I don't want you to delete the 0. So yeah, okay. 3 dots. Can you do 3 dots? Yeah, enter. Okay, go up again.
If Alfredo, if you just download it and copy and paste from the downloaded file instead of the preview, I think that would work.
Oh, también,
Because he's
yes,
just previewing it and go, see? So just download that, open it.
that's right.
Yeah.
Otherwise, sometimes you have text. Yeah, that one. Yes. Yes, you got it.
Oh,
It was
you
a
got
it was
okay.
a text version, so it captured like a text. Hey,
Okay, so yeah,
Karina,
it's
can you
gonna
check that, please? So download the document, download the Word document, and then save it. Once you have opened the Word copy, paste it. It should work.
Okay, let me see.
Yeah.
It's still not going for me. I'm not sure why.
Can you share your screen very quickly?
Yeah. Because when I'm downloading the file, it comes up as a Pages document, not as a Word document. So I don't know, maybe that's the issue.
No, that's the issue because it's saving as how do you call it? As a text document. So that the numbers are not numbers, are text. So that the first thing you need to do is save it as a yeah, no. Can you go to the Word document?
Is it here? Can you see it?
No, the
Okay.
Word document, I don't see it. No, the Word. So when you download the document,
mhm.
save it as a Word document.
Okay. Let me see if I do it through here.
Yeah.
Okay.
Really, guys, for while I work with Karina, all of you guys, can you create a matrix that only contains the income of individual number one? Okay? Only the income of individual. Let's call this A, individual of individual number one. Can you show me your screen, Karina, so we can
Yeah. Sorry.
the Word document? Have you downloaded the Word document?
Whenever I try to, it keeps coming up as a Pages. I'm not sure why.
Do you
have-
have? Yeah, go
You
ahead.
can open it in Google Drive and then copy and paste from over there if you don't have Word downloaded. So open with Google Docs.
Okay.
I just tried it, so that should work for you too.
Perfect.
And then download it as a
No,
Word.
then
No,
just
no.
scroll down and
Just
copy and
copy.
paste
Oh, okay.
from here and it should work.
Yeah.
Let me see here.
Yes, you have it. Perfect. Thank you, Trevor. You're officially my assistant.
Thank you. I got
Okay. Thank you. Okay, guys. So let's go now. So you have if you where's my word? Just click on panel data. You should obtain something like this. Do you agree? Okay, so I will give you some things that I want you to do. So let me stop this one here. Oh, let's do this together. No, let's do this together. And then you have exercises for you later. So let's share this one. Okay, guys, what I want just the income of individual number one for all the 5 years. So I want this 1,125, etc. I want this part here. Okay, let's call this a vector A. So I will do one, and then we do all this together. So what I want is to find. So remember, guys, rows are years, the columns are individuals. So this is individual 1, 2, and 3. The first matrix is income. The second one is savings. Agree? So what I want from here, if I'm asking to you, give me all the years for individual 2. No, sorry, individual 1, and only income. This should do it, right? Correct or not?
That's correct, Prof. I tried it. Yeah.
Yep. So now what I want from you, just as a matter of practice, I want the savings of individual 3 for all the years. Savings of individual 3. Let's call this B, okay? Savings of individual 3. So all rows 3, but savings are located in the second matrix, correct? Everyone? Okay. Create C, and C is going to be the following. I want to know the percentage savings for all the years for all individuals. Percentage savings means simply savings divided by income for all individuals, all years.
You said savings divided by income? No, or the other way around.
Savings divided by income.
Divided by income.
Yeah,
Okay.
so it's the percentage of income that is saved.
Am I supposed to get 5 columns for that one? Or no?
You should have, no. You should have 5 rows, 3 columns.
Got it. Okay, thank you.
Okay? So C should be equal to what? What mathematical tool do I use? So it's going to be everything, right? Everything to what? These are my savings, correct? For all years, all individuals. I want this to be divided by the the first phase. But this is going to be element by element division, correct? So this should be it. Make sense or not, guys? And guys, this is one of the things that happens. The higher the income, I will share with you one of the documents that we are just finishing, one paper we just finished with one of my co-authors, is that the impacts of inflation and tariffs, supply chain issues on income by quartiles, by deciles. Okay, and of course, who are the ones that suffer the most? The 40th percentile, the 40 guys down. Do you agree with that? This is related also with the K-shaped economy or the E-shaped economy that we are going to discuss later in the class. But makes sense to you? So the more you make money, you cannot eat everything. You cannot pay a lot of rent. You cannot travel all the time. So this is normally what happens. If your salary really goes up like that, your salary normally goes up like that. Okay, and your consumption is more or less stable. The consumption doesn't go this way. Consumption goes up to a way, then you're stable. You cannot eat more than what you can eat. You cannot go. There are only 360 days in a year. You cannot travel more. Do you see these numbers here? Do you understand these numbers? Okay, so we stop here. Now, guys, I completely forgot about telling you something. Oh, yeah, the homework. It's not a homework, really. This is not a homework. This was supposed to be done in class. If you have the Word document, the one that I sent you, I want you to do, just as a matter of practice, this one here. Okay, that is based on the last part that we have done, guys. Got it? Makes sense? So now, normally, guys, the dynamic of the class. Normally, I don't, give me 1 second, where's my mouse? Oh yeah, here we go. So normally what happens, guys, I don't do breaks. I just go straight forward. And so that's why I normally finish at 8:30. Today, I don't know why it's almost 9. So, but yes, plan is going to be 8:30, something like that. Got it? Now, in between Monday and Tuesday, Monday and Wednesday, you're not going to have a lot of work to do. But between Wednesday and Monday, I will provide you a lot of things to do. So you can have a lot of, it's practice. Remember, this is like mathematics. You need to practice in order to learn. Okay, so that's why there is a lot of things that you're going to do that sometimes are repetitive, but I do this just for you to memorize the commands, to really understand the concepts, and to just be familiar with all this stuff. Once you're familiar with this stuff, guys, you're going to see that programming looks very simple. Of course, there is more math involved, but the basics are built there, and then you're going to move from there. Make sense? Okay,
Yes,
guys.
thank you.
So we stop here, do this assignment, and then this is the first thing we're going to do next class. And then from there, we move very quickly.
Just a quick question.
Yeah,
We
Lauren.
meet on Friday, right?
No, we don't meet. We don't meet this
Okay.
Friday. I will send you one video that you are going to watch.
Okay.
Unfortunately, my Fridays are crazy for me.
Okay.
So I send you a video. On Monday, we continue working the class. So don't worry about that.
Okay.
Because we don't have exams. So we simply,
Yeah.
we use all the days. All
Okay.
full days we use it for the class.
So there's no makeup because of that email they
No.
sent out. Perfect. Okay, thank you.
No, there's no makeup.
Okay.
But you're gonna
Yes.
work more than 10 days in this
Yeah.
term.
Yeah.
Don't worry about that.
Okay, cool.
Okay.
Yes. Thank you.
And
Okay,
then
guys.
is this
Yes.
homework 1 or is this just practice?
No, this is
Okay,
practice.
just checking.
Yeah,
Thanks.
this is practice. I
And
will
then-
send you
yeah.
homework 1 if you can. Yeah. No, let's do Monday, and then I give you homework 1. You're gonna be working on homework for Wednesday, but that's okay.
Okay.
You're gonna have time.
All right.
All right.
Okay,
Thank
guys.
you.
Have a nice weekend. See you
Have a
later,
good
guys.
night.
See
Take
you.
care.
Bye bye.
Bye.
Take care. Bye.
Good night.
Good night.
Bye bye.